Hello girls, this is chapter 11, section 3. The title of the section is Properties of Waves. Before we start talking about the properties of waves, let's start talking about the two major types of waves. The first type is called electromagnetic waves. Examples on electromagnetic waves: X-rays, gamma rays, microwaves, ultraviolet rays, infrared rays, visible light. Those waves, or this type of wave, we will not study it in this section. We will focus on the other type of wave, which is mechanical wave. Now, the main difference in between, just keep it in mind that in electromagnetic waves, they transfer through space, vacuum, and they transfer as well through medium, okay? While in mechanical waves, they can only transfer through medium. A famous example on mechanical waves could be sound waves, water waves, the waves that you create if you are holding a rope and you tie the other end to a doorknob, for example, or the waves that you can create with a slinky. All those are examples on mechanical waves. Now let's start. As a beginning, you should know the definition of a wave. A wave is a disturbance that transfers energy through matter without transferring matter itself. Okay, keep in mind that all forms of wave, they transfer energy, but they don't transfer matter itself. Okay, now in here, they started with this title: a wave is the motion of the disturbance. In order to have any kind of motion, you should start with a disturbance. Okay, this disturbance will cause vibrations, and those vibrations will carry energy from one point to another. Like in this picture here, the person's hand is the source of vibrations, or the source of disturbance actually. Now, once this hand start vibrating the rope, waves will be formed. As I said, mechanical waves, they can transfer only through medium. A medium, if you will give a definition for it, it's a physical environment through which a disturbance can travel. Examples on medium could be any kind of solid, any kind of liquid, any kind of gas. Okay? Now, in here, the title is explaining the two types of wave. Okay, for in general, waves, they can have one of two forms. Okay, the first form, we call it transverse wave. A transverse wave will take place if you hold a rope and you shake it up and down in this way. Okay, as we did in class, we remember when we chose two girls. Both girls, they were holding the rope or the slinky from in between. There were a distance in between, and they started vibrating the slinky up and down. What you have observed in class was at that moment called a transverse wave. If you check here, you can see that a transverse wave has a high point and a low point, and so we call this high point a crest, we call the low point here trough. Okay, we call this line that represents the x-axis, that, if you want to say, cuts this rope into two symmetrical parts. Okay, the upper part and the lower part. We call it the equilibrium position, which is the rest position of this rope. Okay, now transverse wave can be described by what is called a sine wave. A sine wave is one of the trigonometric functions, y equals sine x. You will not be solving for y equals sine x, but if you will be asked to draw it, you can simply draw it like this shape. Okay, it has a high point, curved shape, going downward to the lowest point, which is the trough. Now, more details to give about a transverse wave. And here you should know that if you are tying the rope at this end, like in here, and you have the chance to vibrate it, okay, while holding the other end, by shaking the rope up and down, the direction of the wave itself is taking place from wherever your position is to the other direction, okay? Horizontally, that means the direction of propagation of the wave takes place horizontally, while the vibration of the particles, the motion of the particles of the rope, they have vibrations vertically, up and down, like this shape, okay? So a very important information to tell about transverse wave: the direction of the motion of the wave is perpendicular to the direction of vibrations. You should know that the distance between any two crests or any two troughs is called a wavelength. We give this wavelength a letter similar to an upside down Y, okay? We pronounce it lambda. So lambda is technically the distance, the horizontal distance between any two troughs or any two crests. Whether you measure it this way or that way, you have the same exact measurement, okay? In general, you can say that wavelength is the distance between any two successive points, okay? Yeah, that means whether you are talking about two successive crests or two successive troughs, this is the wavelength. Successive means it takes place after each other directly. That means if this is crest number 1, this is crest number 2, they will be called successive because they happen after each other. If there is a third crest here, okay, it's not successive to the first one because there is another crest in between. Now, one more information. This is called the equilibrium position, represented by the x-axis. The y-axis is represented by displacement. Displacement, it's the change in position from the equilibrium position, okay, to the new position of the particle. For here, it's the highest point, which is the crest, and in here it goes to the lowest point, which is the trough. The distance between the equilibrium position and the highest position, which is the crest, or between the equilibrium position and the lowest point, which is the trough, the distance, whether it's this part or this part, we call it amplitude. What do we call it? It's written here, amplitude, okay? The amplitude represents the amount of energy the wave carries, okay? So the higher the amplitude, okay, the greater the energy. The lower the amplitude, the lower the energy. Actually, amplitude and wavelength, they have no relation in between. Amplitude and wavelength, they do not depend on each other, they are not related. If you will relate amplitude to sound waves, for example, the higher the amplitude of a sound wave, the louder the sound is, okay? The louder the sound, the lower the amplitude of the sound wave, the quieter the sound is. That's it for transverse wave. I hope that you copy all the highlighted parts here, all definitions that are mentioned, and solve the questions that are related. That's it for transverse wave. I will explain the other type of wave, which is a longitudinal wave, in a different video. Thank you.